Yeah, this time it's a dog. Everybody who ever owned a ZX Spectrum knows this tune. We found it in chapter 19 of the user's manual, and it was our first experience with computer generated music and sound. I don't think it sounds as impressive in the 21st century as it was in the 80s. But it's what you call nostalgia. To produce a sound, the only thing the Spectrum wanted to know was the note and its duration. And if you had a friend who was able to read music, he could convert your sheet music to beeps. Or something similar. All you had to do was to key it in. And there you got it. Something to accompany your stunning graphics. Now, I never was the guy who tried to relive his computer memories by replicating them in hardware or software. No, what I did was to port some stuff and incorporate them in the programs I wrote. So there's a VIC editor I still use. And the tape verification algorithm hidden deep in 40H. One of the example programs in 40H started its life as a ZX Spectrum type-in. Some of the graphics examples were ZX Spectrum programs. You can use the ZX Spectrum randomizer in 40H. But I couldn't replicate the ease by which I created these beeper programs in those days. Now, you can try to create WAV files, but although doable, it's not that easy. So I tried something else, MIDI files. First I tried to nix some simple false MIDI libraries, but most of these simple libraries were whoppers with far too many features. I just wanted a beeper, not some polyphone, multi-channel AY38010-9 sit chip thingy ding booms. Just single channel, single track, just beep, that's all I ask. Then I came across this page. It started by creating a MIDI file that played the middle C for a second, and that's all I needed, because middle C is just a beep. And after one beep comes another beep. And after enough beeps, you got a song, capiche? Simple as that. So I started by just writing a header. I wasn't interested in what it all meant, nor did I want to change all those values. Full disclosure, I'm a programmer, not a musician, nor did I want to become one. Last time I tried, people begged me to give it up, after just 48 hours of practice, so, no. The only interesting and quite necessary thing here was the so-called chucklen of the track. Because without correctly writing that one, the whole thing wouldn't function. In the beginning I just did the math and filled this field manually. I would take care of it later. By the way, MIDI files have a few quirks. I mean, they're big endian to begin with. And then the delta time, aka the time between events. It's measured in tick diffs, where 96 tick diffs form a quarter note. Now those delta times have a peculiar format, which kind of reminds me of UTF-8. If delta time exceeds 7 bits, the 7th and subsequent bits are moved to the next byte, or the previous byte, if you take its address into consideration. And, on top of that, the most significant bit of that byte is set. Now, the maximum value 2 bytes can express in this format is 16,383. That's an excessive amount of time, which you'll only need when encoding the more avant-garde oeuvre of the contemporary music. So I settled for 2 bytes. Good enough is good enough. Next question, how do I play a note? Well, MIDI has events. Pressing a key is an event. Releasing a key is an event. And in between there are the doors, the note. Every event is preceded by a delta time. So the difference between the event pressing and the event releasing is effectively the duration of that note. Now, time in ZX Spectrum beep is measured in seconds. Time in the MIDI file is measured in quarter notes. Now, how can we convert these? Well, frankly, I just winged it. When I played both musical pieces and timed them, they finished at about the same moment. That's good enough for me. If you got a better method, leave it in the comments. Now, how can I translate a beep to a MIDI event? First, having worked out the tick diffs per seconds ratio, I decided to use 100th of a second as a duration unit. That way I could avoid the floating point seconds of the ZX Spectrum. Second, I decided to define a note by using these 4 elements. 1. The delay, a pause between this note and the previous one. 2. Pressing the key, effectively the start of a note. 3. The duration of the note. 4. Releasing the key and consequently the end of the note. In short, 2 delta times and 2 MIDI events. And that's the note, pal. Now, admit I'm getting close. The only thing missing is the pitch. Remember, the ZX Spectrum defined middle C as 0. In MIDI, the middle C is 60. So I just have to add that offset to the ZX Spectrum note. And everything will be hunky-dory. Ending the track, that's not a problem. That's an event. Easy. All that's left to do is to create a word to write the note to a MIDI file. And yeah, I defined beep. What do you think? That's what started all this. But there's one more thing to do. Without it, it won't be a valid MIDI file. Let's face it, we have to calculate and write the chucklen field. How do we do that? Remember we opened the MIDI file and wrote the header? Well, part of the header was actually part of that track. And the last 4 bytes written by that header actually form the chucklen. So if we retrieve and save the file pointer at that position, we know 2 things. The chucklen field starts 4 bytes earlier. If we subtract this value from the final address of the last written event, we got the value of chucklen. And that's how it's done. And now for the moment suprême. Will it beep? Well, it doesn't actually beep, it pianos. Because that's the default instrument. We'll fix that next time. And ending with the astonishing revival of this 45-year-old ZX Spectrum beep program. I'm Hans Beesmer, and this was Back and Forth.
Hey, just checking in. We're about halfway through the video. What do you think so far?